Okay, so today we're going to be doing box and whisker plots. So again, the key terms that we need to make sure that we know for our vocab quiz. Box and whisker plot, you circle all the 1, 2, 3, 4, and 5. Each of those and what they are. Your interquartile range and outliers. Also, add the word range. That'll be a word that I forgot to put it in the notes, but put it right underneath the outliers in that space right there, and we'll add that to the notes. So box and whisker plot, data broken up into 4 parts using 5 different numbers. The first number is our minimum value, the third number is our median, and the fifth number is our maximum values. Left 2 and 4 out just for now. So box and whisker plot is basically just taking a median 3 different times. So number 3 right here, that's my median, so that's cutting my data in half, which means I have half the data between 1 and 3 and half the data between 3 and 5. The points 2 and 4, the lower quartile and the upper quartile, those are just finding the median of the lower half and the median of the upper half. And so what we need to make sure we understand is that 25% of the data, so 25% of the people, 25% of the dogs, whatever it is that your data is representing, 25% of them fall between points 1 and 2, 25% between 2 and 3, 25% between 3 and 4, and 25% between 4 and 5. So there are the same number of people in each one of those sections. The interquartile range is just the distance between the points 2 and 4. It's basically just the distance of your box, how long the box is in your box and whisker plot. Outliers are going to be values that are much lower or higher than most. So you're talking about everyone in a class gets a C, and then one person gets 100%. That's an outlier because they're the one person that's different than the rest. If everyone gets a C again, and then someone gets 5%, he's an outlier, or he or she is an outlier because his point is so much farther away from the rest. Range is the distance between the minimum and the maximum. So our highest point and our lowest point. That's all range is. And so when I do this, the first way I'm going to show you how to do it, like this is a dot plot that has 80 points. And so to use the cross-off method is kind of difficult because that's a lot of crossing off, and it gets kind of tough. Also, you're going to find 3 different medians. You're going to find the median 3 different times. Once for the entire set, once for the lower half, and once for the upper half. And so kind of an easier way of doing this, go ahead and circle those 80 viewers. So again, a median is just finding the middle point of 80. The middle of 80 is 40. And so what I can do is I can count my dots. I can actually count going from left to right. I can go 1, 2, 3. I can count all the way up to 40, which is half of 80. The 40th dot is this one right here. And so, again, since it's an even number of numbers, the median is going to be in between that point and the next point. So this is going to be my median right here. Again, I want to find, that's going to be my median. That's my third point of my box and whisker plot. The next thing I want to do is I want to find the median of this lower half and the median of the upper half. And so when I do that, I'm going to, again, count. In this lower half and the upper half, there are 40 dots. So the middle of 40 is 20. So I can count all the way up to 20 dots. Right there is the 20th dot, and so again, it's in between the next 2. So my 40 is going to be my my lower quartile, or that second point on my box and whisker plot, where my box starts. And then I can do the same thing with the upper half. Count to find the 20th dot. The 20th dot is the second dot there, and so I know that this will be my fourth point, my upper quartile, the end of my box. And so when I make my box and whisker plot, I'm going to do it right above my dot plot. So here is my minimum value. Here is my maximum value. and then my box starts at 40. So I've got my start of my box there, end of my box here, and then there is going to be my median, which again is going to be where my half point of all my data is. Then I can connect the dots with my box. So again, what's important to remember here is that 25, this is talking about people watching a TV show. So 25% of them are from 5 to 40. There's 25% of them are from 40 to 60, 25% from 60 to 70, and 25% between, that's 75. So I got 75, put the values above each one of these. This is 5. And so one thing we have to realize is that, so if I were to say which one has more people in it, the whisker from people that are from 5 to 40 or the people that are from 70 to 75, they're actually the same. There's 25% in each one of those intervals. What the stretch out means is that up here with the 70 and 75, there are it's a tighter cluster. There are more in less age, so there's more people. There are like the same amount of people in a less amount of age, and then same thing over here. That bottom pink just means there's the same amount of people, but it's stretched out. It's not as clustered. And so, again, like we did yesterday, this is going to be a left-skewed graph, or left-skewed dot plot, which means that our median is a good number for that kind of approximates our data. So our median is 60. Go ahead and write that down, actually. Again, it's important to realize that's my median. So my median is 60, which means that most of the people watching this show are around 60 years of age. If you look at your dots, most of them are, in that interval between 40 and 75, older people. And so, again, if we were to think about what type of TV show would this be, it would be a show that maybe older people like. It may be some sort of older show, something like The News or Golden Girls or Andy Griffith's Show, something like that. So that's a free game problem to ask on any sort of quiz. Is what type of show do you think this would be based on the data? My IQR, again, is going to be my distance or the length of my box. So going from 40 to 70 is 30 years long. My regular range, rather than my IQR, is the distance going from the minimum value, 5, all the way to the maximum value, which is 75. So that would be 70 years long. Okay. On the back, same thing. I'm going to make a box and whisker plot for female scores and then for male scores. So when I make my, I want to find my median, and then I can find the median of each of the halves. So again, I can do the cross-off method here. Just like we did yesterday in our notes. It's kind of tricky when they're in rows and columns like this. Just make sure you're always doing the smallest number minus the biggest number. And so again, the last two are in between 65, so my median will be 65. And then I can go ahead and I want to find the median of the first half of data, which is the one I just highlighted in green. Oops, including that 65. And then the second half of the data, I'll find the median of what I just highlighted in pink. Okay. So again, to do that, I can make these X's. Oops. So I can go, again, I'm going to start with 10 and then this 65 here. Once you get here, again, make sure you're going littlest to biggest, little to big. So 40 is going to be my median there. And the next one Again, smallest to biggest. And so those are my 5 points. I've got my minimum value, which is 10, my maximum, which is 76, and then I've got my 40 and 76, along with my median, which is 65. So when I draw that, I'm gonna put them actually together. So I've got 10 as my smallest value, 76 is my biggest. This is gonna be 76 right there, and then I've got 40 as the start of my box. 65 is the middle of my box, or not the middle, that line that's somewhere in the middle, and then 76. This one's actually a little weird because the end of my box ends up happening at the same point that my maximum value does. And so there's my box and whisker plot. And so when I do this, one thing that we want to make sure we understand is that this area right here, since I'm that contains the right half of the box and a whisker, so in that space right there is going to actually be 50% because my maximum value is the same as my upper quartile, and then I would have 25% here and 25% here. I can go ahead and do the same thing with the next one. So with the male scores, same thing. Again, once I get here, the smallest value and the biggest value. It's a little tricky when they're in rows and columns like this. There we go. Oh, I messed it up again. Where did I mess up? There we go. So there's my median. It's going to be 30. And again, when I find the median of the lower half, I'm going to find the median of the ones I highlighted in green, not including 30. So I have removed 30 from my data. And so I'm finding those are the two different medians I'm finding, the green and the pink. So when I do that, in between there, in between it gives me 25. And then here, yep, in between those 40s as well. And so when I make my my box and whisker, there's my minimum and maximum value. And then I've got 25, 30, and 40. So when I do this one, there's my 15. There's my 50. Got my beginning of my box is at 25 and 30. And the end of my box is 40. So there's my box and whisker plotting. So again, just thinking of some differences between the male and female scores. With the females, I can see that overall the scores are higher or better. The top of the page talks. This is about leadership. So we have higher scores of leadership. 60 and above is advanced leadership, and so this is higher leadership scores. It's also widespread. So your range goes from 10 to 76. We could also say you can see that. Again, most of our data is falling in this category right here. Half of it is all the way up at the top, up between in those two, in that half of the box and whisker plot. So I could say that actually this one is left skewed. Because most of my data is in the right-hand side of this, and then it's going to drag all the way out to 10. That's going to be my tail going to the left. So again, one of the things I could say is that females in this test, at least, were better leaders. with the males, overall the tests were a little bit lower. None of them had a score that was considered advanced, which is bigger than a 60. It's more, I'm going to say, clustered, because you have kind of a bunched together box and whisker plot. Again, you've got half of your data between 25 and 40. 3/4 of it between 15 and 40. So it's more clustered together. And it's, I'm not going to say it's symmetrical, but it's more symmetrical than the other one. So it's not skewed one way or the other. It looks fairly balanced. So with the last one, again, just a quick note right here. That is it's one way that we can show outliers on a box and whisker plot. If you see asterisks or dots that are apart from the whisker, so like my whisker would end here and here, that would be the maximum minimum. Outliers, again, would skew the data. And so what you can do is you can mark, or you may see, a box and whisker plot with asterisks or dots on the outside, and those are going to be the symbol for our outliers. And so we're going to put this as 18. And so we want to see what percentage of people are between 0 and 18. And so that's going to be 50% of the people that are in this part of my graph. And then the one question that we need to make sure we understand is which has more in it. People that are under 18, so which is the one I just circled in blue, or the ones that are greater than 18, which is the one that I just circled in red. So I've got this data right here. And I've got, again, we're gonna take out those outliers and just talk about the box and whisker plot. And what we have to realize is that which one has more people in it, they're the same. Neither one is bigger. What it means is that between 0 and 18, it's more clustered. And then 18 plus is widespread. That's something we have to know, is that the length of the box and the whiskers don't mean there are more people in there. It just means that it's more widespread, the data. So this would probably be one that has a tail to the right, and so this one would be right skewed.
Please excuse the interruption. Students who are part of leadership mentoring, you are